Hi everyone, this is the video that goes along with Worksheet 1.1, Logarithms, Factorials, and Exponentials. And before we get to the actual worksheet, I'd like to tell you a little bit more about how logarithms work. So you may want to get out a piece of scratch paper to help you out with this. All right. First of all, let's consider the following problem. If I've got 1,000 equals 10 to the xth power, then that's technically an algebra problem. And if you were clever, you might realize that if x equals 3, then that's going to satisfy this equation because 10 to the power of 3 equals 1,000. But if you've got a more complicated problem like 5.2 equals 10 to the x, then how do you solve that? And the answer is that you use logarithms, which you probably learned about in high school, but I'm just going through the rules again to help remind you because we use logarithms a lot in PChem 1, and I want to make sure that you've got it down as well as possible. All right, so to solve this particular problem, what you'll need to do is take the log base 10 of both sides. And what that will result in is log base 10 of 10 to the x, and this is just going to result in x. And when you use your calculator, it won't say log base 10, it will just say log, most likely. And we've got log and on most calculators, and we've also got the natural log, which I'll talk about more in a second. And if you plug this whole expression into your calculator, you will get the correct answer for x. So what's the right way to think about what does a logarithm mean? Well, to me, what it means is that it's the number x that when I raise 10 to that number will equal 5.2. That to me is what log base 10 5.2 means. So really it's a perfectly valid way to think about it is that it's the algebraic opposite of an exponent. Like if I've got the number 10 down below an exponent, then I can use the log base 10 and that's going to be the opposite of that. All right, moving over to the worksheet, I've drawn this fairly crude table here with two columns to highlight a technique that I learned in high school that my math teacher taught us that was really helpful for me, where he differentiated what happens in the real world versus what happens in log land. And the difference between the real world and log land is that in the real world, that's what occurs outside of logarithms, whereas log land is what happens inside of logarithms. So if you're adding something in the real world, then you multiply it inside of logland. And if you're subtracting something in the real world, then you're dividing it, you're dividing inside logland. And if you're multiplying in the real world, then it becomes an exponent inside of logland. All right, allow me to demonstrate to you specifically what this means using real examples. All right, what I want you to do in a moment is to pause and use your calculator to figure out what's the log base 10 of 5, and then write that number here. The log base 10 of 8, write that number here. Then recognize that if I've got a multiplication inside of logland, which corresponds to an addition in the real world, then I get the log of 40. So go ahead and calculate the log of 40 and write that here. So pause and do that now. Okay, I'm assuming that you paused and now you're unpaused and that you calculated and wrote down each of the numbers. And the numbers that I got was 0.699 here, 0.903 here, and 1.602 here. Notice that if I were to take these two numbers and add them together, I will get that one, even though you calculated this number separately because of that multiplication there inside logland. All right, let's take a look at this next example down here where we've got a subtraction in the real world. According to our table, a subtraction in the real world corresponds to a division inside of logland. And what that will mean is that the number with the negative in front of it is the one that goes in the denominator on the bottom there. So this will be log 30 divided by 10, or log of 3. So go ahead and pause that and calculate these three numbers now. Okay, unpausing, we've got 1.477. Log base 10 of 10 is just 1. And the log of 3 is 0.477. Yeah, so I forgot to write that, log base 3. Notice that if I've got 1.477 and I subtract 1, then I get this number here. So whether we did the division inside the log going this way, or we did the addition outside of the subtraction outside the log going this way, we get the same answer. And that's the key thing to recognize about these logarithms. Now down here, if I get the log of 2 and multiply that times 3, then I'm going to get a certain number. But recognizing that I can take that 3, which is being multiplied times the log, and looking at the rules of logland, that a multiplication corresponds to an exponent, then this will equal log 2 to the 3rd power, which is just log 8. So go ahead and pause now and write those two numbers down here. Okay, unpausing, what you get is you get 0.903 over here, and you get 0.903 over here. See that these two are exactly the same. All right, let's flip over to the other side of the worksheet now, where, just to review, that if we've got an algebra problem set up like this, where a equals b to the power of c, then what this means is that I can multiply, or I can take the log base b of both sides, and I'll get that c is equal to the log base b of a. And that's how we solve problems that involve exponents using logarithms. A very special logarithm is the natural log, as you probably already know. And what the natural log is that it is the log base e, where e is a number that occurs often in nature, and it's approximately equal to 2.71. The last subject that I want to touch on is, what if you've got a strange base to your logarithm? Say you don't have 10, or you log base 10, or you don't have a log base e problem, but you've got a log base 2 problem. And there's a trick for doing this, where since you don't have a log base 2 button on your calculator, you can use one that you do have, like log base 10, and put the a in there, but then you divide by the log base 10 of the base that you do want. And if you use the rules of logarithms and you work this out algebraically, then you'll see why this is true. Okay, moving beyond the logarithms, let's go into the factorials. Hopefully you remember that some number with an exclamation point after it represents factorial, and the factorial is just that number times that number minus 1 times that number minus 2, all the way down to 2 times 1. So therefore 4 factorial is equal to 4 times 3 times 2 times 1, which will equal 24. So go ahead and pause right now and write down what 6 factorial is and practice plugging it into your calculator. Go ahead and pause now. Okay, what you should have written was that 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, which is 720. And I'd like to point out one last thing about factorials, is that 6 factorial is equal to 6 times 5 factorial. Yeah, and then that is equal to 6 times 5 times 4 factorial. So these factorials all sort of contain each other, interestingly. Now, on to the last section of the worksheet with exponents. There's these three rules that I want you to make sure that you have down as well as possible. These rules of algebra that you may not have seen for a little while, and you should be able to internalize these before we go too much further in the class. A to the power of b plus c is another way of saying a to the b times a to the c. So make sure that you can flip that expression back and forth as you need to. The next example I'm going to show you is that a to the b to the power of b times c can also be written as a to the b to the power of c, or equivalently a to the c to the power of b. So make sure that you're able to flip back and forth between these three expressions as you need to. And the last rule is that any number to the power of 0 equals 1. And that concludes our video for today. Thanks for watching. And if anything didn't make sense, please come to my office hours and I'd be happy to talk to you about it. And I look forward to seeing you in class. Thanks. Bye.